Alright, so first problem here, 3.7, number 14, which says use implicit differentiation to find dy dx. Alright, so so first of all, well, what does that mean? Well, we write this out, we can see it's y equals all of this. So really what it means is we're going to take the derivative of both sides. So when we take the derivative of the left side, we really just write that as y prime equals, and what do we got right now? So now we've got, I guess we got a quotient rule, right? So this would be a quotient rule. And as we look at the quotient rule, we got to remember what that is. It's g of x times f prime of x minus f of x g prime of x. And I always write those down when I use them just so I can't possibly mess those up. All over g of x squared. Alright, so top is your f term, bottom is your g term. So g of x is going to be our first term, bottom term, so that's y minus 1. That's the g of x. F prime of x, well, what's f prime of x? Well, x plus 1 just becomes 1. This 1 becomes a 0, and the x becomes a 1. Minus f of x, which is just x plus 1, times g prime of x. And so be careful here. Again, the 1 just goes away, but the y is going to just become a y prime. All right, so far so good. You put all of that over g of x squared, which is just going to be y minus 1 squared. All right, go down to the next level here, y prime. Looking to see if there's anything I can do to make my life a little bit easier. So I think I might be likely to pull that that y minus 1 squared out of the bottom. So let me do this. Let me erase this real quick. Pointer options, eraser. So what would happen if I'm not sure where to go, so what I'm going to do is I'm going to take the y prime over here. Oops, sorry about that. The y prime, and I'm going to multiply it by y minus 1 squared. The thing that I think that does for me is it cleans this whole thing up a little bit. The other thing I might be likely to do here is, well, this 1 can go away. So I know that makes my life a little bit easier, so it just becomes y minus 1 minus x plus 1 times y prime. So it's a little bit neater right now. It's still not perfect. Really would like to isolate that y prime. Let's see. Maybe let's move it around a little bit. I'm going to add this to the other side too. So I get y prime times y minus 1 squared. I'm just playing around with the equation a little bit. So if I add this whole term, which is plus x plus 1 times y prime is equal to y minus 1. See if this helps me out at all. A little bit. You know, again, I'm trying to get all the y primes on one side. Well, the nice thing is right now I have all the y primes on one side. So I feel like that's kind of nice. Y prime times this mess plus y prime times this mess. So really I could factor out a y prime. Y prime times y minus 1 squared plus x plus 1. Oops. That one got a little goofy there, so apologize for that. Pen back up here, pointer pen, x plus 1, close out that bracket there, equals y minus 1. I kind of like that. That looks like it's pretty good. And finally, I could actually solve for y prime. Now this is going to be a little bit messy, but y prime, if I divide all of this side and put it over there, is y minus 1 over y minus 1 squared plus x plus 1. And look at that, we've got a solution for y prime. It's not pretty, but it is a correct solution. Notice what we did here. We had a y prime over here. We worked to get everything that was a y prime across the way. I don't know if this helped me a whole lot, but it wound up helping me quite a bit because I got this out of the denominator and it just cleaned up quite a bit down to that. So that's 3.7, number 14.